All right, welcome back everyone. So in this session what we're going to talk about is metals and really differentiating between ferrous and non-ferrous metals, and in fact we'll look at categorizing a bunch of different metals. So a lot of content in this one, but let's start by just talking about metal in itself and defining the difference between a pure metal, and a pure metal is something we would see on the periodic table. And some examples would be like iron, copper, zinc, and that's different from an alloy, because an alloy takes a mixture of two or more of these metals and mixes them with those metals, and could even be some other elements. So here I see it's a definition: mixture of two or more elements with other elements. So an alloy could be metal A and a metal B with some other elements. For example, brass has copper and zinc, or stainless steel has steel and chromium. All right, so let's, what I want to do is sketch out a little table starting with this idea of just the alloys. So not looking at the pure metal, but I'm going to break down all these metal alloys and starting off with the basic categorization of either ferrous versus non-ferrous. So let me start by sketching this out. So here you can see what I'm doing. I'm taking these metal alloys, breaking it into two basic categories, either ferrous or non-ferrous. And really the difference between those two categories, if it is ferrous, then it has iron in it, or it's based with iron, right? So of course non-ferrous means there is no iron. So let's start with this ferrous side, the iron-based side, and see how we can further categorize that. So there's really two categories we can put it into, one being steel and the other being cast iron. So what differentiates a steel from a cast iron is the amount of carbon within this ferrous material. Now steel will have less carbon than cast iron, and if I were to put a percentage, I would say that steel has less than 2.1% carbon, while cast iron is greater than this 2.1%. Now I can further differentiate, starting with the steels, which have less than 2.1% carbon. Then I can say, well, how much of an alloy is it? And so I can break it into two categories, one being a low alloy and the other one being a high alloy. Now, when we say alloy, what we're talking about are some common alloys would be chromium, nickel, manganese, sulfur, copper, etc. So those are all alloys that we're combining with our steel to get our desired properties. With these low alloys, meaning it's also called, by the way, plain carbon steel. Because it's carbon based, there's not very many alloys. We can differentiate that into three categories based on their carbon content. So I can see I have a low carbon, a medium carbon, or a high carbon. And because there's not very many other alloys, this will really dictate on what the characteristics of that alloy will be. Now, if we're going to put a percentage on this, a low carbon would have less than 0.25% of carbon, and a medium carbon would be like between 0.25% and 0.6%. So these are still really small values overall as far as a percentage of your total material, right? In a high carbon, we're talking like 0.6% up to 1.4%. Well, let's move on over to the cast iron side of things. With cast iron, there are multiple categories there as well. We're going to look at three categories of this cast iron, and those three categories are gray cast iron, white cast iron, and a malleable cast iron. And so we can break those cast irons into those three categories. Let's move over to the other side, our non-ferrous side, that are not iron based. Now we talk about non-ferrous. Now these are alloys, not strictly pure metals. Pure metals would be also non-ferrous, and they could be found like aluminum, which is just an element. But if we're talking about an alloy, there's really three of them that we should be looking at. One of them is brass, another is bronze, and the last is solder. And those are made up, because they are alloys, are made up of multiple elements. So brass, we have copper and zinc. bronze, we have copper and tin. In solder, we have lead and tin. So this whole big thing is the way that we're going to categorize our alloys. So like I said, we start with this idea of being either ferrous or non-ferrous, and then we can break those and subcategorize. On the ferrous side, we either have steel or cast iron. With steel, we have low alloy or high alloy. For low alloy, we have low carbon, medium carbon, high carbon. And on the cast iron side, gray or white or malleable. And then on the non-ferrous side, really all we're talking about is either brass, bronze, or solder. So let's talk a little bit about characteristics of these metals now that we know the breakdown of where they're all coming from. So let's start on this ferrous side. And with this ferrous side, what I'm really concerned with is what's going on down at this final little category, low carbon, medium carbon, and high carbon, and how those actually react, or what are the characteristics. So let's start with a low carbon steel. So low carbon steel, once again, I've already defined this, but we can say that we're defining it as having less than 0.25% carbon. And because carbon is a big part of that heat treatment process, we cannot use heat treatment on low carbon steel in order to make it a tougher or give it a higher hardness. Now, what we can do is we can still use cold working to increase its strength. So what cold working, the process of cold working is, so we haven't really talked much about it. It's really changing, adding strength to the material, to the metal, by squeezing, rolling, bending, shearing, drawing. What you're doing is you're changing the shape without using any heat. And that is subjecting it to the mechanical stress and causes a permanent change in its crystalline structure, causing this increase in strength. So because the low carbon steel can't be heat treated, this is the process that we could use in order to increase its strength. But in general, it starts off as being a low strength steel. But the advantage to that is because there isn't the carbon, which is related to strength, is we have a high ductility. It's very malleable. I can move it around and deform it. And you might recall from our stress strain class when we talked about toughness being the area under the graph, and if we had a more ductile material, we had that long elastic or that long plastic region, right, that flat part of the curve giving us more area, which means it's actually a tougher material before failure. So that's what low carbon still gives us, low strength but high ductility and high toughness. It does have a poor resistance to corrosion. It will corrode easily. And of course, you probably know that all these iron-based metals, iron, when it reacts with water or the humidity in the air, begins to rust. And that's somewhat what we're talking about when we talk about corrosion. You would see this low-carbon steel used in something like car bodies, screws, nails, also in structural steel. But let's move on to medium carbon steel. So as I said earlier, we have more carbon, still not a lot, but we're talking it's above 0.25%, but less than 0.6%. Now, because we do have a little bit more carbon, we can use heat treating to some extent on these medium carbon steels. So as I'm sure you remember, that is a process to increase the hardness of that steel. If we're going to do this, what we should do is we should also temper it, or tempered martensite, once again, because otherwise it would become very brittle, and that's not a very desirable characteristic. This is stronger than plain iron steel, which should make sense because we're adding this bit of carbon to it, and the carbon's what's increasing that strength. However, because we have that carbon, and we're already seeing this direct relationship all over the place, it will be less ductile. And with ductility comes this idea of toughness. So it's less ductile and less tough than iron steel. And then adding even more carbon, we end up with our high carbon steel. So we said high carbon steel has more carbon, so we're starting at that 0.6%, and going up to about 1.4%. So I guess it's important to note, even when we talk about high carbon, we're still talking, barely over 1.5% or barely less than 1.5%. Now, with this, what we end up with is the hardest and the strongest of the carbon steels. However, as we see this trend continuing, when I increase this hardness and this strength, what I end up with is less ductility, which means I can't, with a high carbon steel, it becomes more brittle, right? This should also be heat treated and tempered, same as the medium. When we talk about this high carbon steel, it is an alloy, and typically your high carbon steel will be alloyed with, so it's typically alloyed with chromium, vanadium, tungsten, or molybdenum. And with those additional alloys, what we end up with is a tool steel. And a tool steel, like the name implies, is a good metal to make tools out of because it's a very hard and wear-resistant material. The last ferrous steel that I want to put on here is stainless steel. And stainless steel, its big benefit to stainless steel is it's highly resistant to any kind of corrosion. And this resistance comes from the main alloy, or its main additive, which is chromium. And when we say main, it means that if we look at our percentage of chromium, we are greater than 11% of the total. So there's quite a bit in there. Now, in addition to the chromium, within stainless steel, there is also added some nickel and molybdenum. And what that does is it adds to this corrosion resistance. Within this stainless steel, there are different grades of stainless steel and many types of uses. Probably the ones you're most common with would be like sinks or refrigerators or surgical instruments. And some of that has to do with its ability to be corrosion resistant because if you had a surgical instrument and it started to corrode, you're introducing all sorts of other nastiness into the human body, right? There are 4 different types of stainless steel that you should be familiar with. The first type is ferritic chromium. Now, the thing about the ferritic chromium is it does form very easily, meaning I can mold it into whatever shape I need. But as some of these other materials, the same idea that it is also weak. So easy to move, but weak. The second one is austenitic nickel chromium. And if I mispronounce the austenitic, because I think that's how you pronounce it, don't hold me to it. But let's see, some key things about this is that this is one that is non-magnetic, and also it is relatively weak. So not as weak as the ferritic chromium, but still weak on its own accord. A third would be martensitic chromium, or martensitic. And with martensitic chromium, we are talking about a high strength and hardness, and this one is magnetic. And the fourth type of stainless steel is miraging, or also known as a superalloy. And some characteristics of this is now we do have the high strength, and this is also a high temperature alloy. So using it in applications where you need that high temperature, like in aircrafts and things. This one is also magnetic. Also, under these ferrous materials, we have this other side, this cast iron side, right? Where I said we had gray iron, white iron, and malleable iron. Well, let's start with a basic definition of cast iron. And with cast iron, we have much more carbon. We're talking about 2% to 4%. And what this excess carbon does is it makes the material hard but brittle. Now, one characteristic of that, or one thing that we can take advantage, is that it would be very strong when this metal is under compression. Now, the fact that it is brittle means we can't form it to different shapes like we could with our lower carbon steels. Instead, what we need to do is heat it up to a liquid form, and we need to pour it into a mold, which is called casting, right? So within this cast iron, there's this, I'm really just going to talk about the white and the gray. Malleable just means it has some characteristics where it isn't quite as brittle. But let's start with this gray cast iron. And gray cast iron, some characteristics is that it is good in compression, like cast irons are, like we said. And this one also has good tensile strength. Because of that, it's also good in machinability, meaning I can machine it into different shapes. And then on the other side, we have our white cast iron. And white cast iron is hard and brittle. But its main characteristic that we'd be concerned about is it has good wear resistance. So that's all on this one side for ferrous. There's a ton of information. On the non-ferrous side, the only thing that I was really looking at were this brass, bronze, and solder. So let me do something like that and talk about those briefly to end out this session, starting with our brass. And as I mentioned earlier, brass is made from combining copper and zinc. So, and what this does is it makes it stronger and harder than copper would be on its own, but still far less than how strong and hard steel is, right? Brass is easy to form, meaning it's very malleable. It's also a good conductor of heat, and it is also corrosion resistant. The second type of non-ferrous material we would like to look at is bronze. And bronze is a combination, or it's made by combining copper and tin. It is hard, but as usually comes with hard, it is also brittle. And once again, this has a very high resistance to corrosion. And then the last non-ferrous material or alloy that I'd like to talk about is solder. And the reason I want to talk about that is because you do see it a lot. Where you really see this is in joining metal pieces. Before we get there, let's talk about what it's made from, since I did this for the other ones. This is made by combining lead and tin together. And like I just said a second ago, its main purpose is to join other parts together. So it's other parts that have a higher melting temperature, right? Because you are basically melting the solder and connecting pieces together by letting it harden and connect those two when it cools. So the primary places I think you'd see this would be within electronics, where you have all of your wires soldered up like a circuit board or something like that. Plumbing, if you've ever worked with copper pipes, the way you join all your pipes together is by heating up the solder and letting it suck in. Also with jewelry, if you have any experience with making jewelry, a lot of solder used there as well. So that's what I have for the non-ferrous materials. Once again, looking back, I did a lot of writing today, right? My hand's sore, and definitely got our money's worth hopefully out of this whole thing. But the idea is we have these ferrous and non-ferrous materials. The difference being if they are iron-based or not. Our ferrous materials can be subdivided into steel or cast iron. Cast iron, we have gray, white, or malleable. Steel, we have low alloy or high alloy. With the low alloys, we can look at their carbon content and define them as either low carbon, medium, or high carbon. And for the non-ferrous, we looked at three, brass, bronze, and solder. And we had characteristics of every one of those. So hopefully you found that a little interesting. A lot of material, a lot of content. Let me know if you have any questions or comments, and I'll talk to y'all later. Thanks.